Good morning, everybody. My name is Kedar Dhuru, and I'm here to talk to you through some of our security use cases for AI data centers. I lead product management for Juniper Security, both product development as well as helping with building security strategy for Juniper Security, as well as how we embed security across all of our different product lines to ensure that we can deliver things like secure data centers to our customers. Part of the agenda is to look into some of the use cases when it comes to AI data centers. Praful covered a few things. This is about how do we help secure the WAN and data center interconnect links. We'll talk about using the example of a couple of threats. How can we help focus on the data and prevent data loss? And then one of the challenges we have when it comes to AI data centers is the fact that everything gets amplified. It's got more scale, more performance, more tenancy requirements, and so what have we done to kind of help address some of these challenges? So that's kind of the structure of what we'll follow today.
I think that's key. Can you say that again? More scale, more latency, and what was the third one?
Multi-tenancy.
Okay.
And I think this is not new. I think both Vikram and Praful have covered these to a large extent in the first two sections. So they apply to security as well. And then we've implemented higher performance, higher scale, and multi-tenancy capabilities into our security use cases too. So when it comes to AI data centers, it's about being able to deliver or run data centers closer to where your data, where your users are, where your applications are running. You want to have data centers be local and regional. Sometimes you want to be able to train your data in one location, move it closer to where you can deliver inferencing. Maybe it's through a public cloud, or it's in a co-location facility. But essentially, you have different locations where your data is located, different locations where your data centers are going to run and access this data. From a protection and a security standpoint, essentially, you have 3 or 4 different use cases. Many of these apply to standard data centers. And when we look at AI data centers, they don't necessarily, they evolve, but we break them down into 4 different areas. You've got data centers that need to connect to each other. And so you want to be able to protect traffic between those different data centers. You want to ensure that the data centers are up and running. Somebody's looking to bang on your door and take that data center service down. You want to ensure that that doesn't happen. So things like DDoS protection become important. The next use case is as you are allowing traffic users or other kinds of traffic to get in and look at your applications, you want to be able to secure that north-south traffic. So you've got the data center edge or data center perimeter firewall, which is where you want to focus on the application. You want to focus on network level threats. You want to be able to weed out the bad stuff with things like threat feeds. You want to be able to identify zero-day attacks or zero-day threats in some way. And so how do we help do that? The third one is, once you get inside the data center, you want to be able to ensure that you can do segmentation. If you've got something compromised, it is not moving laterally within your organization and compromising other applications. Or I think one of the examples Praful used earlier was going from one tenant to another tenant, from one user's data, compromising somebody, accessing somebody else's data. So you've got things like the data center core firewall addressing your inter-DC use cases. And then as we, when we looked at the architecture or the high-level diagram for data center and how they're distributed, you may also want to take some of your data into the public cloud. And then how do we bring these same use cases into the public cloud? I don't think it's anything new. It is still the same data center perimeter firewall, data center core firewall functionality. It just needs to it needs to be adapted to operate in a public cloud environment. Breakup between, using the AWS terminology, breakup between different VPCs. Ensure that you've got secure connectivity into the cloud and so on. Same thing applies to Azure, GCP, or wherever else you're running your data and workloads. Let's look at two things. One is from a WAN and data center interconnect standpoint. You want to ensure that every data center that is connected, or all of the data centers that you have connected, have a link that is in some way protected. So the two things we do here, and what we have done, is we have ensured that if you are doing some kind of a connection between, let's say, a firewall, the SRX is our product, our firewall product line. The MX is our data center kind of gateway and routing product line. If you do have a connection, how do we ensure that that data center is up and running? So we integrated DDoS mitigation capabilities into our data center gateways, whether that's MX or the PTX product line. We can detect somebody doing things like volumetric DDoS attacks meant to take down your applications or your data center links as a whole, identify those, and then start blocking against those DDoS attacks there. The second thing is, when you do have these connections, many times those connections may not have a dedicated link. They may be going out over a high-performance public link, the public internet. And so you want to ensure that when you're moving data, your customers are bringing data to a...
Kedar, one question before you go on to that. Jack Paul, our Paradigm Technical. So you're making a distinction there on public links. Is there a reason you're doing that? Or is you behind a firewall? Are you looking at zero trust at all in this environment?
So we are looking at zero trust, and I'll come to that.
Okay.
But in this particular case, we're just looking at the WAN link. You're looking at an open public link where if you're transferring data, you may want to bring in a level of encryption. That's where the IPsec piece comes in.
Right.
VPN IPsec. And many times, and when it comes to AI data centers, it's moving large volumes of data.
Right.
Some of that needs to happen at high performance, but if your IPsec links are few gigs, you're going to act as a choke point. So some of the things we did was, whether it's the SRX, which is running as a firewall, or things like the MX, which are your data center gateway, we can do high-speed IPsec connection, all the way up to single flow being 300 gigs.
Right.
So whether you have a public link or even if it's a private link, if you do have a need for encryption, you do get that high-speed capability.
All right.
Does that answer your question?
Yeah, I just, in the context of AI, is it performance that's driving the need for not using encrypted links versus encrypting your data all the time, right? So from a general data security point of view, we want to encrypt all links all the time.
You want to encrypt links all the time. Yeah.
Right, yes.
Yes, and we can help do that.
Right.
I was just being, it's up to the customer,
Okay.
the operator, how they want to do the encryption.
Right.
I would recommend doing it all the time, but that's me. You might have a different design.
Okay.
So it's flexible.
I just want to make sure that there wasn't some specific reason we were doing.
No,
No.
no,
Okay.
it's a choice.
Yep.
But we made it easy, and we built it in the product. So if you had to turn it on, it's a couple of lines of code.
Yep.
Right, so it's there, and I'll come to this in the last slide. But essentially, if you're doing a few gigs of encryption, most products and most firewalls can do that.
Yeah.
If you need, what happens with AI data centers, you're moving large volumes of data. Your strain on your IPsec connection is also not a couple of gigs, could be tens, could be multi-tens of gigs.
Yeah.
And so you need higher performance. That's available as well.
Gotcha. Thank you.
So, like I said, single flow. I think because we are using, we built this into the Juniper ASIC to be able to do IPsec. That's looking at 300 gigs of single tunnel performance. So
Gotcha.
you've got that wide range. When it comes to security for AI data centers, I think I'm just using this slide to level set. You've essentially got your back-end networks, you've got your private front-end networks, and things like your public front-end networks. When we break these down and we look at some of the different security use cases that show up there, you've got things like data loss, data contamination in the back-end networks. You may have, you don't want intermingling of data. That's where the multi-tenancy piece comes in. On the private front-end networks, you've got, obviously, if you've got something compromised, if you've got a compromised machine learning model, which is what the example we'll see, you have IP theft or data loss that can potentially happen. And you've got tampered models that you want to be able to detect. And then finally, on the public front end, you want to allow the right kind of user authentication. You want to do intrusion prevention. You don't want somebody to come in and waste your resources. So these are the different use cases that we were looking at from a security standpoint for the different kinds of networks. We're going to use
explaining these at a higher level. So back end, those could be hosted. They could be in your data center.
They could be in your data center. If you want to run training models, you could be using somebody else's data center where you move data, or you're running your training models, right? So you could be using an
Google Cloud,
AI data center as a service.
NVIDIA's, and then so private front-end. What do you mean by private front-end and public front-end?
Okay, so a private front-end is essentially your data centers where you've already got you're using models, you're bringing them down, an LLM model, and you're running it against your data set to whether it's within your organization to be able to do analysis. For example, on the threat research side, we may be using a LLM model for doing threat analysis. We may bring different kinds of data. We may bring data from our honeypot information. We may bring data from customer submitted information. We may bring publicly available information. So that's where we're running all of our inferencing and to get the results. And then public front end is if you're running an application that you want to have as a front-end app. This could be just any other kind of public app that's connecting to an LLM-based service on the back end, and you allow a large number of users or even publicly registered users access to those applications. I guess.
So either coming in or going out to the public. Okay.
Like a ChatGPT front-end interface.
And private is on-prem, intra-company.
Intra-company or within your organization.
Okay, thanks.
So other than Kimberly Bates, other than tracking movement of data, how else are you detecting the data threat? Especially when you talk about things like model taint.
Correct. So that's the example I was going to use in the next slide. So
next slide. Okay. Well,
set it up.
Well done. Way to go, Kimberly.
Okay.
We talked about this earlier.
Yeah.
But essentially, I mean, the example I think Praful brought this up. You've probably heard about this in the news. Is things like publicly available marketplaces like Hugging Face exist to be able to share and different kinds of models. What you are doing is a user's probably downloading some kind of a model to their private front end, in this particular case, to be able to run against their data sets. And let's say the model is compromised. I think that's one of the use cases. That's one of the things you were asking, right?
Yes, I'm more saying, okay, so I'm bringing a model that's already been compromised in. That's a totally different thing than one of the things that I'm very worried about is that once I have created the model and I've deployed the model, somebody goes in and alters that code.
And how would you know?
How would you know? That's the one that scares the crap out of me, is because I'm like, okay, so I'm putting out these models that are running, let's say at the edge.
Correct.
Water, monitoring electricity or whatever. And it's at that edge that somebody goes in there and does something. I'm going to think about somebody, whatever. And that's kind of the place that.
So when somebody goes in and tries to tamper with the model, or any application, there's potentially a few things happening. One of those is
Oh, I'm sorry, I wasn't even tapping. All that brilliance went away. Sorry. Still here a little bit. Go ahead.
do you want to re-ask the question? Okay, so the question is, you've got a model, you've trained the model, you've deployed the model, and somebody goes in and alters the model, and how do you protect against that?
Yeah.
Right? So from a network standpoint, that basically means a couple of things. When you've got a model that is tampered on, that's looking at your data, and if it's doing nothing else, one of the challenges there is that giving you the right outcomes for the data that you had trained the model for. The second one is, if you have tampered and played around with the model, somebody is looking to do something with it, potentially exfiltrate data or communicate with and give access to somebody outside the network, a backdoor into the network. And so those are things that we can look at, and we can identify to see malicious activity or malicious behavior. We can either block those, or we can report on those that allow you to go in and investigate further. So that's what we're looking at from both of these use cases. In this particular case, I'm bringing in a compromised model. I bring that onto my network, and essentially, when I install that model is looking to open a backdoor to somebody that's giving them access to my network. So how do we detect some of those different things so that we can stop you from bringing in a bad model, identify a bad model if it has already been brought in, and be able to minimize the impact of that, keep it contained. So those are the two different use cases. And essentially, the first thing is, if you're bringing in a bad model itself, we have two firewalls in this particular example. You've got
Kedar,
firewall A.
Is it fair to say that what you're really doing is you're detecting that your threat detection, what threat protection is looking for specific IOCs, indicators of compromise. In this case, you're looking at things that are network related as indicators of compromise. So you're looking for, if you see somebody coming in to look at the model that isn't doing it, or that shouldn't be looking at the model coming across the network.
So in this case, you're downloading a model, right? And just to set this up, we are using two of those four use cases I mentioned earlier.
Right.
You're using a data center perimeter firewall, and you're using a data center core firewall. Right? And if you're downloading a model that is compromised, that firewall is capable of detecting a compromised model. We've built in a machine learning algorithm onto the firewalls itself that is capable of looking at indicators in the file that is being transferred. So if you've got a model that somebody has tampered with, or whether it's an AI model or it is an application that has been tampered with, there are certain signatures in the file that is being downloaded itself that indicate that somebody has tampered with it. For example, if they're using a old unsupported version of Visual Studio to make some of the changes. That's one example.
Right.
And then you've got other markers that we can look for.
So
when you aggregate all of those, that gives, there's less chance that somebody good is using bad software to create, a product.
So you're doing more than just looking at network intrusion.
We're looking at the actual.
So more than just network effects, network intrusion detection, some of those types of things. So you're actually doing an inspection of the data being downloaded and saying, this is
model
not
being downloaded in this.
I'm sorry.
Of the software being
software. Sorry, software being downloaded and saying, we expect a model to look like this, and this model has signatures in it that it shouldn't have of one form or another, that are indicators that it's been tampered with.
Yes, and that can give you a lower level of probability, which you may want to alert on, and a higher level of probability that you may a threshold that you may want to block.
Right.
So that's one use case.
Yep.
Bringing in something. Now, let's say you brought it in anyhow before you had security in place, or through another mechanism, and you've now got that model that is compromised. It's trying to connect and commute. That's it? I have 5 minutes? Okay,
Right.
let's speed up then.
On the solution.
So that model that's trying to communicate with a threat actor's
Right.
infrastructure. This typically happens. I mean, why is somebody compromising your model? They want your data. They're not doing it for fun. They want your data. They want to be able to get into your network so that they can move laterally, so they can get to something else. If it is critical infrastructure, for example, they may want to take over more and more applications in your critical infrastructure. So if that's going out, then that same data center perimeter firewall has several things. It's got direct signatures like command and control feeds that we know where there are known threat actors, IP addresses, or infrastructure IPs that we can block against. Typically, these models are looking at different IPs, looking at connecting to different kinds of domains. So things like domain generation algorithms or DNS security can be used to help protect that. We built another machine learning algorithm called encrypted traffic insights. Even if your connection to the thread infrastructure is encrypted, there are a lot of markers in that encrypted tunnel. The IP address it's connecting to, the handshake, the certificates, all of these, the beaconing behavior that is there, all of this can be used to save the high level of confidence that that model is compromised, is talking to some kind of a threat actor's infrastructure, and we need to block that, or we need to report on that. And then finally, one of the things that happened with the Hugging Face model corruption was a lot of the models put in like a reverse shell connection. And so being able to detect those can help you identify a compromised model in place or compromised application in place and help block that. The third thing, everything's come in, everything's running. Now you've got traffic flowing from this model, not just to your data, but trying to go somewhere else. That's where the data center core firewall comes into play, and it is able to identify traffic moving from one model to a different data set, that movement across multiple tenants of data, and you're able to help bring that in. If we have detected that my model is compromised, we have a feed that we can share directly with the QFX switches in the data center called the infected host feed. So if I detect my firewall here has detected my IP address to be malicious, I can share that with the QFX itself, and you can help contain and block the compromised IPs or servers within that environment. So that's more about reducing the spread there. And finally, we have introduced things like multi-tenancy capabilities on the firewall itself, so we can help prevent or block an unauthorized application from talking to somebody else's data. So again, this is more about containment.
How would this protect against like the people who want to tamper with your models, not to exfiltrate data, not to go other places, but to poison your business decisions and that kind of stuff internally? And then that sort of also relates to the second question about what about insider threats doing all the same?
So the insider threats, again, that's where you have the data center, so I'll just take that one. That's where you have the data center core firewall, which essentially is you have access to this application, not to this application. So that's more about where you have access to. That's implementing things like a zero trust security approach. So I'm the insider, I have access here, but I'm trying to go in here, but I don't have access to an application X. That's where zero trust based policies would apply. So things like a universal zero trust architecture integrating with your Active Directory, so you can set the right kind of permissions, that's where it would apply. And I think the other one is, I do have a compromised model, I'm giving you bad data. I'm giving you a bad response. That one's a little bit harder from a network and firewalling point of view, but we are looking at ways where, we're kind of, that's in the research phase. We understand that's a challenge, but a network-based approach necessarily can't solve that. That's more between the model and the data. So you need to look at the data level, you need to understand model context. So those are a little bit different.
So
Since you're
how do
about
you?
to get the hook, will we have time to get more ask
Yes.
more
Well,
questions?
I did have a question following up on Karen's
Okay.
question, which is how do you handle what would be unprotected Ethernet traffic like RDMA traffic?
Can we take that later? I don't have an
Okay.
answer right now. Okay.
Okay.
Can I get 2 more minutes to finish up?
You need to finish up in the next 30 seconds.
Okay, 30 seconds. So everything gets amplified in an AI data center. We talked a little bit about this. It's much higher performance, it's much higher scale, and obviously multi-tenancy. So we have been thinking about these challenges for a while. We did take some steps to get there. The first thing is we started shipping a new one rack unit firewall that can do 1.4 terabits of network throughput with multiple 400 gig, 100 gig links to allow you to connect into your data center fabric itself or AI data center fabric. All of those ports can do MACsec. And then the other thing we did was we introduced machine learning and algorithms into the software code itself to be able to detect AI-based threats, things like using AI to be able to detect malicious or compromised models. We introduced integration directly into an IP fabric like EVP and VXLAN, so we can make it easy to integrate security into your data center fabric. That allows for multi-tenancy, that allows for multi-tenancy across a data center stretch. And then finally, I heard a lot of questions earlier about scale up versus scale out. So we introduced a concept called scale out firewall, where you can connect multiple of these firewalls together. They act and function as one logical firewall rather than having to treat them individually separately from an operations point of view, from a CLI management point of view, and everything.